Sleek eel body, unhinged jaws, trident fangs. If this description don't paint a terrifying portrait, then let me elaborate. The frilled shark is essentially a moray eel infused with the stuff of worst nightmares. Those jaws extend and distend, unfolding onward to swallow prey whole. And each one of the 300 teeth lining that maw, a jagged, hooked trident bayonet. This isn't a shark, it's a deep-sea creature that will leave you shaking. The frilled shark has been dubbed a living fossil for good reason. While most modern shark species date back around 100 million years at most, the lineage of this ancient mariner can be traced back over 350 million years to the late Devonian period. Back then, the planet's landmasses were clustered into a single supercontinent, and the oceans teemed with bizarre armored fish and the first primitive sharks. The key lies in the incredible life strategies and biological systems that evolution has equipped the frilled shark with over the eons. Let's start with its diet. This predator dines on a wide variety of prey, including cephalopods like squid, bony fish, and even other smaller sharks. To snatch up such active, mobile prey, the frilled shark possesses a secret weapon: its bizarre jaws. Those slender, eel-like jaws are attached to the skull via special ligaments that grant them incredible flexibility and an almost unhinged mobility. This allows the frilled shark to thrust its gaping jaw forward with incredible speed, aided by its muscular body coiling up and then releasing like a spring. The inside of those gaping jaws is a nightmarish row upon row of backward-curving, trident-shaped teeth, perfectly designed for snagging and impaling unfortunate prey. Once prey is captured, the frilled shark can swallow it whole thanks to an incredible ability to dislocate and extend its jaws, allowing it to devour morsels far larger than its mouth would normally permit. But survival isn't just about capturing prey. It's also about not becoming prey yourself. The frilled shark's slender serpentine body shape allows it to tuck away into the nooks and crevices of the seafloor and coral reefs, shielding it from larger would-be predators. Its dark gray coloration also provides perfect camouflage in the dim, deep ocean environment. While its body plan may be ancient, the frilled shark has evolved some surprisingly sophisticated behaviors to survive in the modern marine ecosystem. Chief among these is its ability to undergo daily vertical migrations through the water column, a process known as deal vertical migration. For centuries, frilled sharks remained an almost mythical rarity, with specimens only occasionally dragged up in fishing nets entirely by chance from unfathomable depths. It wasn't until the late 1800s that the frilled shark finally received its first formal scientific classification by zoologists. German naturalist Ludwig Döderlein provided the first specimens gathered during 3 years of research off the coast of Japan from 1879 to 1881. However, his taxonomic notes and manuscript were sadly lost. A few years later, in 1884, Samuel Garman of Harvard University managed to obtain a female specimen from Sagami Bay, near Tokyo. After detailed study, he designated the species as Chlamydococcus anguineus, the frill-bearing eel-like shark. Garman speculated, based on its primitive anatomy, that this was likely a surviving representative of an ancient cohort of cartilaginous fishes dating back over 400 million years to the Devonian. Subsequent findings helped resolve the frilled shark's place on the tree of life more accurately as a very basal member of the modern Neoselacian clade of sharks and rays. But questions regarding its exact closest relatives remain an area of uncertainty and active research over a century later. What we do know is that the frilled shark's niche today, as a denizen of the deep ocean, represents the last evolutionary refuge for a once much more successful and widespread group. Fossil evidence suggests early frilled sharks and their ancestors were prevalent in far shallower coastal waters, only being pushed into the deep by competition with more modern, active shark lineages. So, while the haunting visage of the frilled shark descending upon you from the blackness may look like a creature from the nightmare realm, it's ultimately just a humble refugee, hanging on to existence at the fringes of an ecosystem it once ruled over hundreds of millions of years ago. If the frilled shark's feeding behavior and haunting primordial appearance don't already seem bizarre enough, then its positively outlandish reproductive strategies likely will. Rather than eggs or live birth, the frilled shark is described as a placental viviparous, engaging in a sort of halfway house mode of reproduction that blends elements of both. Females yolk up their eggs as per normal oviparity, but then retain them within their body as they develop into embryos, much like placental live-bearing. The unhatched embryos feed off the yolk reserves in these contained eggs, eventually exhausting their supplies and requiring birth to avoid starvation. This is a far more drawn-out and physiologically demanding process than placental live-bearing, and results in the frilled shark having one of the longest gestation periods recorded in the animal kingdom, between an astonishing 2 to 5 years. All this to produce a litter of just 2 to 15 shark pups. During this long gestation, the mother shark's body becomes heavily lopsided and distorted with the skewed weight distribution. The strain is so intense that her organs are forced to migrate to whichever side has more open space at a given time. It also means she struggles immensely to hunt and feed herself for those arduous years of incubation. But even this epic tribulation barely begins to cover the outrageous strangeness of the frilled shark's birth process. The infant pups gestate within thin membrane sacs that are essentially individualized artificial wombs, the dry run product of 350 million years of evolutionary development before departing into true live birth. When the thin membranous sac finally ruptures, the frilled shark neonate kicks free into the open environment of the mother's uterus in a small cloud of nutrient-rich fluids. This tiny pup, around 16 to 24 inches long, now has a few crucial developmental weeks ahead of it to prepare for life in the blackness of the deep. Within this temporary safe harbor, the newborn shark feeds on the remains of its membranous egg casing, as well as the protein and lipid-rich uterine fluid provided by its mother's body. This phase represents a transitional growth spurt as the pup's anatomy and biological systems shift into their final form for surviving on their own. Most remarkably, during this uterine incubation phase, the young pup develops a set of finger-like external gills that sprout from its body, giving it an even more otherworldly alien appearance. These transitory fetal frill gills help maximize oxygen uptake from the limited environs of the uterus. Finally, after several more weeks inside this biological terrarium, the now fully formed pup emerges to confront the perpetual night of the deep ocean on its own terms. Its frill gills slough off and are reabsorbed as the shark's enclosed gill system takes over. The tiny predator is now ready to fend for itself in hunting whatever it can fit into its miniature jaws. While this birthing process is undoubtedly one of the strangest in the natural world, it makes sense as another aspect of the frilled shark's transitional biology. In many ways, this deep-sea shark represents the halfway house between the ancient embryonic strategies of egg-laying fish and the more modern gestation approach of placental live-bearers. It's almost as if the long-lost ancestors of sharks followed this developmental path for a time before the more derived placental boid won out in the evolutionary arena. While the reproductive strategy and birthing process of frilled sharks is shocking and bizarre enough, some of the raw statistics around their existence are just as staggering. Fossil evidence indicates the frilled shark lineage dates back over 80 million years to the late Cretaceous period, around the time of the dinosaurs. An adult female can reach up to 6.6 feet in length. The jaws contain 300 trident-shaped, recurved teeth arranged in 19 to 28 rows in the upper jaw and 21 to 29 in the lower jaw. They have been recorded at ocean depths of over 5,100 feet, but are most common between 650 to 3,300 feet down. The shark's bellies contain a pair of thick skin folds running the body length. Their function is still unknown to science. These raw facts and figures help quantify just how built for extreme survival this deep-sea creature truly is. Everything about its physiology, from the multi-rowed jaws of hooked teeth to the spacious belly cavity needed for that epic 2 to 3 year gestation, indicates of an organism pushed to the absolute limits of adaptation for its environment. And remarkably, frilled sharks have persisted virtually unchanged through all the environmental upheavals, extinction events, biodiversity revolutions, and climatic shifts our planet's oceans have experienced across over 350 million years of time. Where so many other fantastic beasts of the prehistoric seas fell away, this humble, almost comically bizarre creature lives on. It's equal parts terrifying and awe-inspiring. While humans may now understand the frilled shark at a scientific level far beyond what our not-so-distant ancestors could comprehend, this deep-sea creature still harbors plenty of mysteries that continue to confound experts even today. For instance, despite over a century of collected specimens and observations, we still lack clarity on the frilled shark's exact evolutionary relationship to other modern shark and ray lineages. Its mosaic of primitive and derived traits make it a challenging lineage to definitively place on the tree of life. Some hypotheses, based on emerging genetic and physiological evidence, are proposing to break frilled sharks off into their own distinct evolutionary order separate from other sharks, the chlamydosalaciforms. This would recognize just how unique and distinct this lineage is after persisting virtually unchanged for over 350 million years. Even more puzzling are the pair of thick, fleshy folds of skin found running along the underside of the frilled shark's belly from throat to tail. What possible evolutionary purpose or adaptive role could these curious anatomical structures serve? No definitive answer has yet been found, despite decades of hypothesis and speculation by scientists. Another area of intrigue revolves around the ancient fossil record of what appear to be closely related frilled shark ancestors or cousins, dating back over 300 million years. Many of these prehistoric specimens were recovered from inland fossil sites, implying they may have lived in freshwater river systems or lakes rather than the ocean. If true, this could rewrite our understanding of where this ancient lineage first emerged and how it transitioned into its modern deep-sea existence. After over 350 million years, the fossil trail may still be maddeningly incomplete when it comes to this creature's origin story. The frilled shark is a true living relic from our planet's most ancient of epochs, a biological ghost ship drifting through the perpetual night of the deep, bearing mute witness to over 350 million years of history. If this glimpse into the shocking realms of deep has you thirsting to uncover more hair-raising mysteries from our reality's darkest, most primordial frontiers, make sure to comment your thoughts, questions, and strangest theories below. And if you'd like to stay up to date on the more deep-sea creatures, be sure to hit that subscribe button and turn on the notifications bell. Together, we can continue to unravel the mysteries of the deep, one bite at a time.